everybody. I saw this problem on an SAT prep channel. It was the channel is run by a guy who made an 800 on the math section of the SAT test. That stands for Scholastic Aptitude. And apparently they're letting people use Scholastic Aptitude Test, I think. And they use it to filter out people getting into colleges in the United States, I believe. Okay. So Desmos is technology, and apparently there's parts of the SAT where they allow you to use Desmos these days. Now, this is an interesting question. I think the wording is sort of, it's a fair question, but it's sort of obscure, the approach I took. We'll see what you think. Okay, we're given the equation of a line P in the so-called general form, and we're given another line that passes through 2 points. Okay, so one equation, we explicitly know the general form equation, which we could convert to the mx plus b form if we wanted. All right, here we could figure out the line if we wanted to, but we're just given that it passes through these 2 points. But the big piece of information here that I used in a way different, I think, than maybe the test creators intended. Maybe I'm wrong, I don't know. But I just know this was for Desmos, for some reason. All right, you're supposed to calculate R plus S given that P and Q have the system of equations involving P and Q have infinitely many solutions. And notice we weren't even given the equation for Q. You could find it, But there's a nice takeaway from this. If a system of 2 linear equations has an infinite number of solutions, then the 2 linear equations have the same graph. In other words, they're effectively the same line, just a different equation to describe the same line. And so 2 different equations, there's an infinite number of points on the line, right? So this is a way of saying that we know that 0, 4, and 5, 2 are on the explicit equation graph that we have, okay? And again, this is very easy to, let me give you a quick concrete example of why this is true. Let's say you had 5x plus 3y equals to, let's say, 21. Okay, and you can see right off that a solution to this would be 3, 2, right? 5 times 3 is 15, 3 times 2 is 6, 15 and 6 is 21. Now, if we multiply this by 4, we get an equivalent equation. It's the same line. We multiply it by any constant other than 0. Multiply by 4 just for arbitrarily. So you get 20x plus 12y equals 84. And you can check that the 0.32 is a point on both of these graphs. Both is 32 satisfies this. Look, you get 60 and 24 is 84. Right here you get 6. Yeah, we've already seen this, right? But notice this wouldn't change for an arbitrary AB. If AB was a point, on this graph, it would also be a point on this graph. Okay, so that means that we can justify just substituting 0, 4, and 5, 2 into our explicit equation here. So we can see pretty quickly that 0, 4 being a point on the graph gives this statement. You see this 0 here? It's the same as this 0 here. And similarly, if 5, 2, you get this statement down here. So we have 2 equations, 2 unknowns with integer variables, it appears. So or we can use it that way, I suppose. But anyway, we get this 5 times 193 is 965, no technology required. Now, if you put 4R right over here, since S is equal to 4R, you get 965 equals to 2R. Okay, and that tells us that 965, 965 equals 2R, and that tells us that 965 over 2 is equal to R. Probably going to run out of room here. Now, y'all, if you take this R, and y'all remember we're trying to find R plus S. Okay, again, in a non-technology way. All right. Now, if you take this and substitute it over here, it would become 2 times 965, which is what, 1930? So we get 1930 equals S. Again, y'all, that was obtained without a calculator just by substituting 965 over 2 right here, and you get 2 times 965, which is 1930. Okay. Now, so S plus R, I'll write it just in that order since that's how we have it written down here. S plus R is equal to 1930. I'm trying to leave room here. 1930 plus 965 over 2. Okay, y'all, and I'm going to come down here a little south here. So to get a common denominator, we have to multiply this by 2. Is that 3860? Yes. It's 3860, folks, plus 965, okay? 3860 plus 960. Let me just write it down. 3860 plus 965 over 2. Okay, folks, and I'm getting 4825 over 2. 4825 over 2, which is a perfectly legitimate way to leave the answer. Some people get hung up about that. If you wanted to write that, that would be what, 2412.5 if they insist on seeing a decimal for something like this. The fraction's a little more meaningful in my opinion. 2412.5 is what I'm getting. Okay, but this entire part right here is the sum R plus S without technology. And the fractions aren't that bad to work with. You know, I don't know how much they count off if you just make an arithmetic mistake. Maybe it's a multiple choice test and you could do it perfectly, but just make an arithmetic errors. Maybe that's why they let you use the technology. I'm not sure. But in any event, this is the answer to this particular problem. It was done utilizing a strange statement, let's say. You know, this is an odd statement. It's a theoretical kind of statement. And the key is, can you convert the theoretical statement into something concrete, which we did. This fact here is a consequence of the infinite number of solutions. Okay, so, and y'all, one other way of looking at this, just if you're not particularly happy with the way that went, both of these have the same mx plus b form. They have to, right? Because this is simply a multiple of this, and that factor of 4 would cancel out, right? So both of these lines, which look different but represent the same line, have the same slope and the same y-intercept. Hence, they're the same lines. But as a system of equations, you would write this as a system of equations, right? And discover that everything's satisfied. It like 0x is equal to something or whatever is how this usually works out. Kind of a mindless way of you know. But if you just think about it, this and this have to have the same mx plus b form. It's very clear. You know, when you would factor the 4 out, and you would see that when you were doing it over here. So anyway, that does it. Let me write the answer down again. 4825 over 2 over here. Okay, that's all, folks.